Welcome to the MECH3110 animation tutorial. What we're going to be doing is we're going to be going over how to use the SolidWorks animation features, and we're going to be doing an example of a robot bogie system that is going to be picking up a drivetrain and transporting it from one end of the warehouse to the other. What you can see right now is an example of what your end product might look like. This process is broken up into three different sections. The first section is what I call mate prep, where we start to look at preparing all of the mates that we're going to need for the animation. Then we look at going into this next section called a dry run, which is where we make sure that our model is able to go through all the motions that we'll need for the animation. And lastly, we'll go through into the animation features, which is looking at how we utilize the SolidWorks storyboard to get our final animation. Okay, so let's now start with the first one, the first stage, which is the mates preparation. Okay, so let's get started with the prepping of the environment for the animation. What we want to do is we want to import all of the parts. So I've got a list of the parts that I've already assembled. They're just sitting over here. So the first one I'm going to bring in is the warehouse. That's where everything's going to be sitting on. I'm also going to bring in my bogie assembly. I'm just going to put it over here. I also want to bring in the drivetrain. It's going to sit on this block, so I'm going to leave that there. And we're also going to bring in the robot. It's going to sit on the bogie, but I'm just going to leave it over here for now. Alright, so what we need to do is we need to put all these mates together so that everything's sitting in the right place. What I find is that the warehouse gets in the way and it's a bit annoying, so what I tend to do is I tend to change the transparency. That way I can actually see through. If I actually have to go around and behind, it doesn't impact my view. Alright, so let's start with this this bogie. What we want to do is we want to mate it so that it's on the ground of the warehouse and it's sitting inside these tracks here. So this is the tracks that I've made. So what we're going to do is we're going to go to the mates and we're going to go to our advanced mate, and the first one I choose is a width mate. This is so that it sits directly in the middle of the tracks. For the first selection I choose these two faces here, and for these tab selections here you need to choose what you would like it to sit directly in the middle of. So I'm going to choose the outsides of this inner part of the track and hit OK. And what you can see now is that the bogie now sits directly in the middle of the tracks, which is exactly what we want. It's still hovering in the air, so we need to bring it closer to the ground. So what I'm going to do is I'm going to use a simple distance mate. Now this is in millimeters, it's not what I want to be using. I want everything to be in terms of meters, so I'm just going to change that there. So again, I'm using a distance mate, which is this one here. So what we can do is we choose this top face here and the top face of the warehouse. Now I know exactly what dimension that I'd like, but if you didn't know, what you could do is you can basically just slowly click it down. That's taking forever. And then, okay, so let's see, sort of like, let's take a guess at 0.5. So that's sitting pretty close. In fact, you know, that's good enough. There you can see that there's a small gap on the tracks. This is animation, it doesn't have to be perfect, but I have gone through and done this so that it's sat exactly on there, and I know it's that distance there. So that then makes it sit beautifully on the tracks. Now let's have a look. So that's all good. It's now traveling inside the tracks. There is one more mate that I want to do just to make sure that it doesn't kind of dip through the floor, and that's just a parallel mate. So there's the face of the warehouse and the face of this top part of the bogey, and that just makes sure that it always stay parallel. And that means that our bogey is now going to travel in the tracks as we would like when we get to animating it. Let's see, next thing I might want to do is I might fix up this drivetrain. So right now I would like it to rest on this block, and it's free to move around. So the first mate that I'm going to do is I'm going to use a width mate. No, I might use a, yeah, I'll use a width mate. So in advanced mates, width mate, and just the same thing as before. The first two selections will always sit directly in between the second two, which is these two here. So I select those. Now I'd also like it to sit in the middle on the top. And so I'm going to use an interesting mate called a symmetric mate. To get the right symmetric plane, I'm actually going to go into the feature tree. This thing up here is called a feature tree. And I'm going to go into the drivetrain, and I'm going to pick the front plane of the drivetrain. Alright, so once again, go into the feature tree, down to the drivetrain component, and then I pick the front plane. And now I want that front plane to sit in between these two parts. Like so. Now the last thing that I need is I would like it to sit right on top, and this is a tangent mate. So I want this one here and this one here. No, hang on. 1 second. There we go. I want to make this tangent, so I'd like this part and this part to sit there. And now we get the message that this component is fully defined, and that's exactly where I'd like it to start when I do the animation. Okay, the last thing I want to do is I want to make the robot to the bogey system. Very similar logic to before. I need a width mate to make sure that the robot sits in the middle. So I choose these two sections here. Okay, and now I want that robot to sit in the middle. There's actually two really nice tabs down here that I can pick. One is here, and just one is right there. Okay, so once more, just underneath, there's one here and one there. And if we accept that one, and we have a look from our top-down view, we can now see that the robot is sitting in the middle of that bogey system, which is good. Hovering in midair as well, so let's use a coincident mate on the bottom of the robot and this plane here. Now that's looking pretty good, but we find that if I try and drag the bogey, it doesn't, the robot doesn't follow. So we need to make sure that we constrain it to move with the bogey system. So the mate I'm going to use here is a distance mate. Not that face. I'm going to pick this face of the bogey. And then this one here is a bit of a weird one. I'm going to pick this one because this is the face that's parallel to that face. And we can see at 1 meter it's gone too far. Normally it doesn't really matter where you pick it, it's up to you, but because the way the animations work, it's a little bit fiddly, which will make sense when you see it. I'm going to use a very, very exact dimension. This is just the dimension that I'd previously chosen and then based all of my animations off to make sure that I can demonstrate this. But when you're doing it in future, there's no need to do this if you go through the dry run phase, which I'm going to get to next, and just make sure that everything is going according to plan there. Okay, so let's just double check. Yep, so the robot now moves with the bogey. The drivetrain's in place. Yep. Warehouse doesn't move. Good. So everything's mated and ready. So now we are able to get onto the next section, which is setting up the dry run of the animation process. So now what we have to do is we need to set up what I call a dry run. Whenever we're doing animation work, we need to make sure that whatever we'd like to animate, once we get ready to go to the storyboard, we can actually animate it. So what we do is we make sure that we can physically move all the parts to where they need to be, and I call this a dry run. So for this dry run, all I'm going to do is I'm going to make sure that the robot is able to pick up the drivetrain and then leave. Okay, so what I want to do is I want to set it up so that the robot is ready to move and be in the right position. This is a little bit of trial and error when you first do this. Because I've already set this up before, I know exactly what I want to do. For example, the first mate that I want to put in, which is a distance mate, is I want to put it for this face of the warehouse and for the back of the robot, and I want it to be 0.3 meters, but not in this direction, so I'm actually going to flip that dimension, and this is where I want my robot to start. Now, if we have a look down here at the mates, there's quite a lot of mates there. That's the last mate that I just put in there. What I'm going to do is I'm actually going to select all of these mates for now, and I'm basically going to add them to a folder, and I'm just going to call this general. It's a pretty good idea to make sure that all of your mates are organized for animation, because if you don't know which mates you need to turn on and turn off, you won't be able to animate easily and things will go wrong. So that's the first mate I want to do. Now it's not able to move, which is good, because once I start moving the robot, I don't want it to be able to be moving off this spot. I want it to now rotate towards the drivetrain. So there are a few other things that I want to set up. I want to have a mate that has the robot facing forwards. So I want to use a parallel mate, and I want this face of the robot to be parallel with the bogey so that it's always facing forward. And I've added that mate in, and I'm actually going to rename this mate. So it's a slow double click. Whoops, or you can right click and go to, where's rename? I don't know. Okay, let's go back to the slow double click. And I'm going to call this one robot face forward. So this way I know that this mate, as long as it's active, the robot should be facing forward. Now if I have a look here, the robot can't be moved because it says it's fully defined. What is actually happening here, as you know from when you mated the robot together, it can move, but for some reason this one can't. So if we go and right click the robot over here, so this robot, and right click it, we should be looking for something which calls make flexible. So let me just see if I can find that option. Now, here it is. So right up the top, it looks like a couple of bits of Jenga. We click this one, and basically what this does is it doesn't keep the whole assembly frozen, and now we can see that we can actually move the robot. It's moving like we had previously mated it in the other video. But because I mated this parallel one, the robot cannot move in that direction. So that's fine, that's what I want. Now I also want to get the robot so that it swivels and stays on top properly. So I'm going to choose this face here, and I just want to make sure that it's parallel with the floor. Right. That's just to make sure that the top of the head doesn't swivel or rotate. So there's a parallel mate there. And because I know exactly what I need, I'm also going to put in a distance mate between this part and the floor. And the distance I want is 2.1018976 meters, like that. Okay, so there's the dimension there. And I hit OK. And so that is looking pretty good. That robot can't move again, but that's good. I don't want it to be able to move until I allow it to. So that's fine. But now what we want to do is we want to actually be able to rotate it. So what I want to do is I want to suppress my robot face forward mate. And once this is suppressed, you can actually see I can now rotate this. But because I've put the parallel mate at the top and the distance mate, it won't accidentally move down or move up. It just stays in the right location, which is good. But I want it to face the drivetrain, so I want to add another mate in this time. And this one is going to be called robot face drivetrain. So these two here, parallel, and we can see that the robot snaps to the right direction. And so as before, right, we don't want to lose track of what our mates are, so I'm just going to call this robot face drivetrain. Okay, good. Now that's good. The last thing we need to check is that the robot can actually pick up the drivetrain. So the distance is fine. It's facing the drivetrain. We're going to have to suppress this parallel one here. One sec. Suppress this parallel one. So if I suppress that, we'll see that I still can't move it, which is fine. But now if I suppress the distance mate, which is controlling that distance there, I'm now able to move the robot arm. And all I'm going to do is I'm just going to try and move it nice and close to the drivetrain. Just going to manually move a few things until it's a little closer. There's no real technique here. I'm just moving it closer visually. And now what I'm going to do is I want to make sure that the robot can actually grab it. So what I'm going to do is I'm going to first of all use a concentric mate, and I want to pick this circular face, and then you don't actually have to choose faces, we can choose edges, and I want to just choose this circular edge right here. Okay, so it says that the cylinder and circle are not concentric, and that's because there's a distance issue. So that's okay. Let me just, what I want to do now is I just want to suppress that distance mate that was holding my bogie in place, and I'm going to try and put that concentric mate on again, and hopefully this fixes my problem. So just choose that face, and I choose this one here. Now there's my concentric mate. Now that's looking good. And this means that this is now going to be picking it up right in the center. And I'm going to also use a coincident mate on this face here, here, and here. Okay. And let's have a look how that looks. And the last thing I want to make sure that it picks up and it doesn't sort of swing around is I want to put in a parallel mate right here. So I always want this face and let's say this face here to be parallel. Okay, I'm going to call those there. Now, this parallel mate, this coincident mate, and this concentric mate, I want to add this to a new folder. Right, so right click, add to new folder, and I'm going to call this pick up drivetrain. So you can see that what we're doing is we're making sure that everything is nice and organized to make sure that we know which mates are going to be going to be associated with which animation actions. And the other good thing about having folders is you can suppress all of the folder. So I'm not going to suppress that for now. Now what I want to have a look at is I want to have it go into here, and this time I want to pick out the drivetrain start, where the drivetrain start mates were. So let's see, I had a width mate, a symmetric mate, and a tangent mate, and I want to add these to another folder. Alright, and I want to call this one drivetrain start. So let me just see if I can move below general. Move to mates. Okay, cool. So this drivetrain start, this is what is keeping my drivetrain on that block. So I'm now just going to suppress those, and I should be able to pick up that drivetrain. Yep, here it is. Okay, so that's all good. Now let's just make sure that I can actually rotate back around. Let's see, I suppress this robot. Robot face the drivetrain, and now I can rotate it, and you can see how it's wiggling around, and it's sort of really difficult to get it to face the direction you want. This is why we actually put all these mates in, is to try and prevent it from having too much freedom, because you can see now when I try and move the drivetrain, it doesn't want to move. This is why we have all these extra mates in, to make sure that we make it move the way we'd like. But that's looking good, right? I mean, as far as this dry run's concerned, I'm able to move the robot, and it can pick up the drivetrain, and it can then move off. So let me just, I've got the pickup drivetrain. Let's just unsuppress that robot face forward, and we can see it snaps forward like this. And then let's see what happens if we unsuppress this distance mate here. Okay. Now I got a feeling if we unsuppress this last one, which is the parallel mate, it'll be stuck in that position. Yeah, and we're unable to move it. So we have to be careful about when we want to unsuppress the distance mates, because if I suppress it again and I move this back like this, and I then unsuppress my distance mate, we see that it snaps back into that view that I like. And because those mates that we've got that are specifically restricting the robot's movement, now when I move it, when I move the whole bogey, it makes a lot more sense what I'm seeing, which is the robot doesn't move with the drivetrain, it doesn't do weird actions, it's now going to move exactly where it needs to. Okay, so we're almost done with the dry run. The last thing we want to do is just make sure that it can start where it needs to start. So let's see, I want to suppress the pickup drivetrain mates, and I want to unsuppress the start drivetrain mates, and you can see that snaps it back to where it needs to be. Now I want the robot to face the drivetrain again, so I'm going to suppress the robot face forward mate, and I'm going to unsuppress the robot face drivetrain. Now I'm going to unsuppress the pickup drivetrain. Oh, and it doesn't like that because we're too far away. So let's just suppress that one. Let's see if we can, I see what's going on. We need to suppress the distance and the parallel mate here. So this is a lesson that you need to learn really quickly, is you've got to be really careful to make sure that you don't have conflicting mates. This is why I've put them all in folders, so that I can quickly and easily see which mates are going to be conflicting. So I'll try again, and I'll unsuppress the pickup drivetrain mate. Okay, so now it's attached to the drivetrain. And the last thing I want to do is, can I get it to sit in the right spot if I unsuppress this distance mode? No, it doesn't want to do it. Okay. So let me just suppress that for now. So that's not a problem. This is the distance it has to be. So what I'll do is I'm just going to delete this mate here. This distance mate, distance 3. This mate here I'm going to delete. And I'm going to create another distance mate for this exact distance that will actually sit at. And the reason why we want to do that, right, is because so let me just try that again. I want it to give me that actual distance. What does it say that is? Whoops. Let me just try again. These two made it together. There we go. Now that's the exact distance. It's going to tell you it's over defining the assembly. That's fine. I'm just going to put it straight in because we're going to need this to start the animation. Right. So I want that distance mate, not that one. This one here, this distance mate. That's the one I've just added in. So I'm just going to drag and drop it into the general folder because that's where it was before. Now I'm going to suppress the pickup drivetrain mates. And now this can't move, but that's all good because what I want to do is I now want to just set back up for the animation start. So I'm going to suppress robot face drivetrain. I'm going to unsuppress robot face forward. I'm going to move this one back a little bit so that it's in the right area. And so now I want to unsuppress the parallel mate. And the last one I want to unsuppress is this distance mate here, so that it's all sitting in the right height. Perfect. Okay. And we're now sure that everything that we do for our robot animation, as far as the dry run is concerned, is we'll be able to animate this to do exactly what we need to do. So that has completed what we need to do for the dry run. And the next step will be if we take this into our motion study, which is just down here, this little tab here. What we can see is we've now got a storyboard, and if we click down here, you can see that we've got all of the mates that we had previously, which is why we spend so much time setting up all these mates, is because all these mates here are immediately in the storyboard before we start animating, and that's what we'll look at next, which is now that we've set up the dry run and we know that we can actually physically get it to do what needs to be done, how do we actually use the animation feature in SolidWorks to animate so that we've got an example like we had before.